Hey y'all, welcome back to MathRescue. I'm Andre and I make content to take away the stress of learning math. In this video, we're going to compare a rational function rule to a table and then graph both functions. Take a deep breath, we're going to slow this down and break it apart step by step and make it feel super easy. Let's talk about it. Alright, so on the left hand side we have the function rule, g, and on the right hand side we have a table representing a function which we're calling h. So let's go ahead and let's start off with our function rule. So first thing I want to do is identify my domain. So to find the domain, you want to analyze your denominator. Pretty much everything could be plugged in for x except for things that'll make the denominator 0. So I'm just going to grab our denominator. I'm going to check to see what would make this 0. So I'll just kind of isolate the x here. Divide both sides by 2. So x cannot be negative 2. So my domain is going to be all real numbers except for x equals negative 2. All right. Holes. So holes only occur when the numerator and denominator have common factors. That's not the case here. So there are not going to be any holes. Vertical asymptotes. So anywhere where we have a discontinuity, so discontinuities could either be holes or vertical asymptotes. I kind of already explained how we get the discontinuity that is a hole. So in this case, our only discontinuity will actually be our vertical asymptote. When you enter in your answer for your vertical asymptote, it's a line on the graph. So it's very important that you enter it as an equation. So our vertical asymptote is the equation x equals 2. For our horizontal asymptote, there are 3 cases for horizontal asymptotes. We like to look at the degree of the numerator and the degree of the denominator. In this case, we have a linear on top as well as a linear on the bottom. So degree 1, degree 1. And in that case, what we do is we take y equals the leading coefficient of the top over the leading coefficient of the bottom. And we create a ratio between them. And so in this case, my horizontal asymptote would be 1/2. All right. So let me go ahead and enter that in. Okay. For the x-intercepts, we look at the numerator. So anything that makes the numerator 0 will create a 0 on the graph. And so I'll just take my x minus 3. I'll check to see what makes that 0. And so at x equals 3, we should have an x-intercept, aka a 0, aka a root. And actually, let me put that in as an ordered pair. That way we don't get it confused with the vertical asymptotes. So I'll just go ahead and put 3, 0 there. All right, solving for the y-intercept is the same as it's been with linear functions, with quadratic functions. The y-intercept is always going to happen where x is 0. So essentially, we're just going to plug in x equals 0, and then we're going to see what the corresponding y value is. So let me do that calculation really fast. We get x minus 3, 2x plus 4. We're going to plug in 0 to both the numerator and denominator. All right, from there we're going to simplify, so we get negative 3 over 4. And that is the value of my y-intercept. Okay, so we found all the key features, and essentially what we would do from here is use those key features to start compiling together the graph. Now there's some additional key features that you could use to definitely help you out. These are the typical ones that I see being assessed with students that I'm tutoring or in my own personal classroom. But other ones that you might see would be like end behavior near the asymptotes, as well as just your end behavior in general of the function. End behavior being like if it's approaching a specific value or if it's going off to infinity or negative infinity. This skill that I'm doing here, I refer to it as analysis. I always encourage my students to do their analysis using the Desmos grapher. That way, as you're kind of doing things symbolically, as I just showed how, you can also physically put it on the Desmos grid and actually physically see a lot of these things. So like, for example, the vertical asymptote, if you type in x equals 2 and you already have g graphed on Desmos, you'll physically see the vertical asymptote run through g. So highly recommend kind of taking that approach with these. All right, let's check out the table. So the table is going to be done the same way, except we're just going to kind of change our frame of reference a little bit because the information is organized differently. The first thing that stands out to me are, and I'm going to keep these colors consistent. The first thing that stands out to me are these three table values. I see we have 0, -3, so that's probably looking something like that. And then we have 2, 3, so that's probably looking something like that. And so at x equals 1, we have a vertical asymptote. So let me go ahead and record that. Because of that discontinuity at x equals 3, we'll also say that our domain excludes 3. From this table, there are no obvious holes to me. A hole has to be a discontinuity, and there's nowhere else on this table where I'm seeing undefined. Because of how our values are decreasing and approaching a constant. When I say our values, I'm talking about the y values, so where it says h of x. You can see specifically these two right here. They're starting to move downwards a little bit slower. That indicates to me that we likely have an asymptote at y equals 1. I'm taking a bit of a guess here because we have limited information. I can see an y-intercept. So right here where we have 0, -3. We plugged in 0 for x, output's -3, that's our y-intercept. And I didn't notice it before, but we also have our x-intercept here. So that's where y is 0. We get -2, 0. All right, and then same thing for this. When you go to graph this, what I would do is I would take your table here, and on the top left corner, left is this way, on the top left corner, my camera's backwards. On the top left corner of Desmos, There's a little plus button. You hit that, you press table. You can enter in all of these values, and from there, there's going to be like a scatter plot looking line with like dots on the outsides of it. You press that button, and it opens up the regression tool, and then you can select. They might have rational function regression, so you could check on there and make your table into a rational function. If you found this video helpful, please like and subscribe to support the channel. I post videos regularly. My goal is to make you feel super confident in math. See you in the next one.